Welcome to The Explainer. Today we are diving straight into the architecture of AI truth. We're going to look at exactly how senior AI architects systematically eradicate fabricated information from large language models. Basically how they transform them from, unpredictable guessers into highly reliable enterprise engines. Let's get right into it.
So to really grasp why this matters, let's kick things off with a massive, incredibly high-stakes scenario. This shows exactly why solving the hallucination problem is an absolute, non-negotiable necessity. Just imagine a healthcare AI assistant. It's tasked with reviewing a patient's chart and recommending a medication. But what happens if it confidently hallucinates a lethal drug dosage? Yeah, it's a terrifying thought. In enterprise AI, a hallucination is absolutely not just some funny little quirk. It's a critical system failure. We literally have to figure out how to stop this.
Here's our roadmap for today's explainer. We'll hit the AI hallucination problem, look at the specific types of hallucinations, dig into the context bottleneck, build the hallucination firewall, and finally, apply it all to zero-error healthcare.
All right, part one, the AI hallucination problem. It is time we confront the hard truth about why even the most perfectly trained, massive language models still end up making things up out of thin air.
Okay, here's the absolute crucial point you need to understand. AI models are essentially probabilistic guessers. Sure, larger models memorize more patterns, but they don't truly understand facts the way you and I do. They're basically engaged in this endless process called next token prediction. So when the evidence is missing, they just generate plausible but entirely incorrect information to fill that gap. Because this is hardwired into how the models are built, hallucinations can be drastically reduced, sure, but never completely eliminated by training alone.
Moving on to part two, the types of AI hallucinations. Because to fix the problem, we first have to accurately diagnose the specific type of hallucination we're actually dealing with.
We really need to make a major distinction right here. On one side, we have what's called an intrinsic hallucination. This is when the AI is given the cold, hard facts, but it actively contradicts that provided context. On the other side is an extrinsic hallucination. This is where the model confidently introduces brand new, totally unsupported information that was literally never in the context to begin with. It just invents it.
Now, digging a little deeper, we also have to determine the actual source of the failure. Think about it. Did the system grab the wrong files to begin with? If so, that's a retrieval hallucination. Or did the system actually grab the right files, but the model itself just went completely off script during the generation phase? That would be a generation hallucination. Knowing exactly where the error happens is a game changer because it dictates exactly how we build our defenses.
Which brings us to part three, the context bottleneck. Let's see how this all compounds when we examine the actual mechanical limitations of how an AI processes data.
I want you to think of the AI's context window sort of like a crowded, noisy room. As that room fills up with more and more documents, the model's attention quality naturally starts to degrade. When that happens, important facts get diluted, basically washing away in this massive sea of text. And the direct result? The probability of a hallucination shoots way up.
This mechanical limitation creates a very specific, honestly pretty dangerous risk known as the lost-in-the-middle phenomenon. Because of how transformers, which is the underlying architecture of these AI models, are built, they naturally focus their attention on the information at the very beginning and the very end of a prompt. If you bury vital, say, life-saving information right in the middle of a massive block of text, the AI will frequently just ignore it entirely. It's wild.
And this is exactly why how we feed data to the AI matters so much. This brings us to a concept called chunking. If you break your data down poorly through a bad chunking strategy, you end up with missing context and broken data relationships. You practically guarantee retrieval failures, which, as we just established, guarantees hallucinations.
Okay, section 4, the hallucination firewall. Now that we thoroughly understand the disease and how it manifests mechanically, let's actually build the cure.
So here it is, your comprehensive 7-layer firewall for any enterprise AI. Notice that we aren't just crossing our fingers and relying on the model to just be smart. Instead, we are wrapping it in prompt guardrails, we're validating its retrieval, re-ranking documents to push the most relevant facts right to the top, grounding its generation, verifying its citations, forcing it to self-verify, and finally, leaving a critical escape hatch for human escalation. It's the whole shebang.
The very first line of defense in that massive stack is applying guardrails. These are essentially hard-coded mechanisms that strictly enforce the rules of engagement. They police the prompts coming in, the generation happening in the middle, and the outputs going out. It ensures safety, compliance, and factual consistency before the AI even attempts to formulate its final answer.
Now, behind those guardrails, architects deploy some truly advanced validation techniques. For instance, they use verifier agents. These are independent AI models whose absolute only job is to fact-check the main AI's response before the user ever sees it. They also utilize graph-RAG to map out how concepts relate to each other, meaning they retrieve complete, interconnected ideas rather than those isolated, easily misunderstood chunks we talked about earlier. They even use something called constitutional AI, where the model follows a strict set of core principles to actively critique and revise its own output.
As for the self-verification layer of the firewall, honestly, the engineering here is genuinely brilliant. You've got chain of verification where the model actively generates baseline answers and then meticulously double-checks its own facts after the fact, revising if it needs to. Alternatively, there's self-consistency. This is where the model generates multiple different reasoning paths all at once and mathematically selects the answer that has the strongest consensus among them. It's just an incredibly clever way to force reliability.
But wait, how do you know if your firewall is actually doing its job? Well, you have to measure it. Architects rigorously benchmark hallucination reduction using specific evaluation tools like DeepEvil, RAGAS, TrueLens, and Phoenix. They're testing for hardcore metrics like faithfulness, meaning is the claim truly faithful to the context, and groundedness, meaning is every single claim firmly anchored in trusted, retrieved evidence.
Of course, building the firewall in a lab is one thing, but once it's deployed out in the wild, you must actively monitor it for hallucination spikes. You're tracking things like dropping faithfulness scores, frequent user corrections, and citation failures. By setting up strict alerting on these specific metrics, you can pull the plug or redirect the system the very second confidence thresholds are exceeded.
Okay, final section, zero-error healthcare. Let's bring all this dense theory right back to reality. How do we actually use this incredible 7-layer architecture to resolve our initial terrifying medical scenario?
Well, we engineer safety by structuring our system very deliberately. First, we use domain-specific RAG. That means we strictly hook the AI up to pull only from approved, verified medical knowledge bases. Second, we demand mandatory citations that trace back to specific source passages. Third, we enforce strict confidence thresholds. And fourth, if that confidence calibration flags an uncertain response, we trigger an immediate escalation to a human clinician for review.
This structured architecture dramatically reduces the danger for sure, but I want to leave you with this final thought to chew on. Since these models are fundamentally built on probabilistic next token prediction rather than absolute reasoned truth, will there ever be a day when we can completely remove the human from the firewall? Or will our safety always, fundamentally, depend on the boundaries we build around the machine? Thanks for joining me for this explainer, and keep questioning the architecture of the technology you use every day.